Okay, everyone, before we begin working on these problems, I want to give you guys just a basic visual of how the general form of your diagram should look like whenever you're drawing them and you're showing me your work. Well, imagine for a second here that you have a cannonball that's being fired from a cliff. As a cannonball is being fired, its path is going to look something like this. It's going to look something like a half parabola. And why is that? Because remember, it's moving in the y direction as well as moving in the x direction. Look at the cannonball's velocity in the y direction. Remember, since gravity acts in the y direction, the cannonball's velocity should increase. In other words, it should be speeding up as it's moving downward. And we clearly see that. Notice how the initial velocity starts off at 0 meters per second and then it increases until the cannonball hits the ground. But notice what's happening with the velocity in the x direction. Remember what we said a few weeks ago, that what's happening in the x direction is completely independent from what's happening in the y direction. Since there's no forces acting in the x direction, notice how the velocity stays constant in the x direction. In this case, it stays constant at 100 meters per second. And clearly you see that because look at this arrow in the x direction. Notice the arrow in the x direction just stays constant. This arrow here is showing us the magnitude of the x velocity, whereas the second arrow here that's pointing downward is showing us the magnitude of the y velocity. And notice how it starts off with no arrow in the y direction, but then it continuously increases in the y direction. Okay, so keep that in mind as we're working this problem out, that both x and y are independent from each other. Now, let's do number one. Number one says a ball rolls with a speed of 2 meters per second across a level table that is 1 meter above the floor. Upon reaching the edge of the table, it follows a parabolic path to the floor. How far along the floor is the landing spot from the table? So everyone, as you all are working on these problems, please be sure that you are drawing a picture of the situation and you're labeling that picture correctly. So to draw this out, here's what's happening here. We have a ball here. It's rolling across the table, and eventually it's going to be launched from the table. And as it's launched from the table, it's going to follow a parabolic path that looks something like this, and it's going to hit the floor. What this question is asking us to solve for is asking us to solve for this distance in the x direction, the distance from here to here, right? Because that's what that means when it says how far along the floor is the landing spot from the table. So ultimately, this is what we're looking for. So let us label this picture with everything that's given. We're given the initial speed or the initial velocity of the ball the moment it was launched from the tabletop. Okay, and so it tells us that it was launched with an initial velocity in the x direction of 2 meters per second. Okay. We're also given the height of the table. We're told the height of the table from here to here is 1 meter. So this height here is 1 meter. So we're going to label that. So with this information, we can solve for the distance in the x direction. This is ultimately what we're looking for here. Now, whenever you guys are working out this problem on this first page, this is the main equation you're going to need right here. The displacement equation that we derived at the start of the school year. Using this displacement equation, you guys can work out these first 5 problems easily. Now remember, in all of these situations, we're treating the y component as if it's independent of the x component. In other words, we're treating them as if they're separate things. So we're going to begin by focusing on the y component first here. And starting off, what we want to find first, we want to find the time in free fall. So that's what we want to find first, because once we find that, we can then use that information to ultimately find displacement in the x direction. So finding the time in free fall, we can use our displacement equation. I'm going to write this displacement equation here. The initial velocity times time plus 1/2 times acceleration times time squared. Now, In order to solve for this t here, to get this t by itself, because that's going to tell us the time in free fall, let us plug in what we know. Okay. Let us first begin with the initial velocity in the y direction. Well, that's easy. You guys know that, because think back to the cannonball scenario. Remember when I said that when the cannonball is launched from the cliff, it's launched with an initial velocity of 0 meters per second here, and then the velocity increases in the y direction. You see it here. So the initial velocity starts off at 0, and then it increases because of gravity. So your initial velocity in the y direction is just 0. So the exact same thing is true for the ball here. The moment the ball is launched from the surface of the table, at that moment, that brief moment in time, the initial velocity in the y direction is just 0. Okay? So if I come over here and I plug in an initial velocity of 0 into this equation, then that means this part of the equation right here just goes away, because 0 times some number is just 0. So this part of the equation goes away, and this equation here just reduces to 1/2 times acceleration times time squared. Okay? And remember, we're focusing on the y direction first. So let us plug in the everything else that we know. We know the displacement is 1 meter, so that's the height of the table. So the distance in the y direction is 1 meter. We know the acceleration of gravity. The acceleration of gravity is just 9.8 in the y direction. And so let's solve for the time in free fall. So 1/2 times 9.8 is 4.9. Now I want to get t squared by itself, so that's 1 divided by 4.9. And 1 divided by 4.9 is 0.204 is equal to t squared. Now, to get rid of that squared, you guys know I need to take the square root. Take the square root here, and also take the square root of the other side. So when I do that, I'm just left with t is equal to 0.545 seconds. Okay. So that's the time in free fall in the y direction. Okay. Now guys, think logically here. If the ball spins 0.45 seconds in the air in the y direction, then obviously the implication is that it also spins 0.45 seconds in the x direction as well. So if we know the time in free fall in the y direction, we know the time in free fall in the x direction. So now let us go back up here to looking at folks. Let us go back up here to focusing on the x direction, or in other words, focusing on the horizontal component. So the time in free fall, the x direction, I'm gonna write that down first. It's just 0.45 seconds. Now let us write down our displacement equation again. Okay. Remember, so the displacement of an object is equal to its initial velocity times time plus 1/2 times a t squared. Okay. Now, guys, let me ask you a question. So when filling in what we know, what do you think is the acceleration in the x direction? Well, remember what we said before. When we launch this ball here, Gravity only acts in the y direction. So if gravity acts in the y direction, that means that there's no forces acting in the x direction. And again, the assumption is that we are ignoring air resistance. There's no forces acting in the x direction, which means there's no acceleration in the x direction, right? The ball just moves at a constant velocity in the x direction. So if I plug in an acceleration of 0 into this equation here, well, this part of the equation just goes away because 0 times some number is just 0. So this part of the equation goes away, and I'm just left with this. That displacement is equal to initial velocity multiplied by time. Okay. Now, we just said what was the time in free fall. The time in free fall was 0.45 seconds. And what about the initial velocity in x? Well, the initial velocity in x is just 2 meters per second. And of course, since the velocity stays constant, that velocity should just be 2 meters per second from here to here. So let's plug in this into this equation. The initial velocity is 2 meters per second. So now, by multiplying those two together, you can find what you're looking for. And that is the displacement of the x direction is just 2 times 0.45. And you put in your calculator, you're going to get 0.9 meters per second. That's your answer. And so there we go. That's number 1. So that means number 1 here, the answer, you can fill this in, is 0.9 meters per, I'm sorry, just 0.9 meters. So 0.9 meters is the distance the ball travels from here to here. That's the distance in x. And that's how you do number 1.